Hello everyone, welcome to another Dragonforce coding episode. Today I'm going to talk about databases, but before I get started, I want to say thank you to all my subscribers. From my last video, apparently I made at least 5 new subscribers, and this really motivated me to upload more videos on this channel. Okay, now first today I will talk about database design with the data normalization and keys. Then I will write some SQL commands to show the process of structuring the database, data queries, combining tables, data manipulation, and data aggregation. Okay, so first, what is data normalization? In my own words, data normalization is a process of making the data more consistent. So let's say if we want to delete certain value under certain attribute in a table, maybe this piece of data is related to other pieces of data in the table. We do not want all the other related data to be removed as well. So in this case, we want to keep them. And in order to keep them, we need the data to be consistent, and we need data normalization to do so. I will explain the concept of data normalization with the following example. Okay, take a look. Here we have an unorganized table. This table is not in any form of data normalization. This table holds the record of students' enrollment status in certain major. However, it's not in the first normal form. So automatically it's not in the second or the third normal form because the second and the third normal form are built on top of the first normal form. Why is it not in the first normal form? Because the first normal form requires each cell under each attribute to only hold one value. And each column should only hold one data type. But obviously under the major and major status column, the cell only hold two values. So it's not in the first normal form. Now this table is in the first normal form. But take a look. Now we have two keys. Originally, we only had one key. The student ID uniquely defines the row. So it had only one key. But now this table in the first normal form has two keys, the student ID and another one, which is the major. Just with the student ID, it no longer uniquely defines each row. So we need two of these keys together to uniquely define each row. Here's a problem. Is it in the second normal form? No, it's not in the second normal form, because if it's in the second normal form, then all the fields must be dependent on all the keys. The fields must be dependent on all the keys. But take a look. Is the number of students, for example, is it dependent on all the keys? No. It is dependent on the major because the major defines how many students it has, right? But is it dependent on the student ID key? No. So it's not dependent on all the keys. It's only partially dependent on the keys. It's not in the second normal form. How do we make it in the second normal form? We split it to three tables. The student table has its own key. The major table has its own primary key. And the enrollment table has its two keys that defines the enrollment status of the student in the major. So if you have noticed, now the enrollment status depends on all the keys we have. So it is now in the second normal form. Is it in the third normal form as well? Well, if it's in the third normal form, then the field must depend on the keys, but not anything else besides the key. For example, if you take a look of this second normal form table, for example, hometown, is it dependent on the student ID? Does student ID defines the hometown? Yes, the student ID defines the hometown. And so does everything else. Everything else is dependent on the key, but not any other attribute. So yes, this is in the third normal form. Okay, now what is the benefit of making this data in the second or the third normal form instead of making it in the first normal form? Okay, the first benefit is that if you want to change certain information, we just have to change it once instead of updating it inconsistently in the first normal form table. For example, if want to update the number of students in the economics major, we just have to change the number here in the major table. But in the first normal form, if you want to update the number of economic students, then what if there are many students who take economics? Then we have to update it in many rows, right? Which is not consistent and inconvenient. This is one benefit. Another benefit is that if we deleted certain students' information in the first normal form, let's say we deleted one Wu, then does it mean that we lost the data of economics in the major as well? As I said, sometimes we do not want all the related pieces of data to be removed with the student information that we want to delete. But if it's in the second normal form, we just have to delete it from the student table. Even if we deleted one Wu from the student table, we still have the information about the economics major here in the major table. All of this makes the table more consistent. Okay, here are the benefits. Now I'm going to show the diagram of this database in order to further explain the concept of primary keys and foreign key. Okay, now let me talk about the concept of primary and foreign keys with this diagram. If you remember, we have the student table, the major table, and the enrollment table. In the student table, the student ID uniquely defines these three fields. So the student ID is considered to be the primary key. In the major table, the major defines the number of students. So the major is considered to be the primary key. In the enrollment table, the student ID and the major are considered to be the foreign keys because they use the keys from other tables to uniquely define the enrollment status. So they are foreign keys in this case. They are pointed back to their parent tables. The student tables and the major tables, the tables that hold the original primary keys, are the parent tables. The enrollment table is a child table of the student table and the major table. Okay, now I hope you understand. Okay, so now I will show you how to write an SQL statement to define the structure of the table in the database by creating the table, altering the table, and dropping the table. First, we want to create a table, and before that, we want to define which database we will use. So I will use the database that I already have. So test db, and then I say create table named TAs, let's say TAs. And then in the parentheses, I define the row, the structure of the row. So I want to say, okay, I'll add a row about the TA ID. So ID integer is a data type of this attribute. And then whenever I insert the TA information, I want the ID to automatically increase by 1, right? So I say identity from 1 and increase by 1 every time. So the first TA ID will be 1, the second one will be 2. So automatically, and then so goes on, right? So yeah. And then I say, okay, another row will be name of the TA, and then the data type will be varchar. The varchar is basically the alphanumeric data type, and then the maximum length I can set to 50. The length of the input can be 50 characters long. Then it should not be empty, right? This input, I make it not empty, so not null. So it does not accept the empty input. And then I add another row, let's say department var char. Length will be 50 as well, and then cannot be empty. Okay. Okay, it has been executed, and then let me refresh the connection to see if we have created the table. Yes, we have newly created the table called TA, and let's take a look at the diagram. Yes, this is our diagram here. Unrelated from our previous diagram, but yes, we have created a new table. Now, what if we want to alter this table? For example, adding a new row, right? We want to make some changes. So we can say alter table TAs, and then, oops, we can add another row. Let's rename the row to be, let's say, age, and then data type will be integer, should not be empty. Okay, and then let's run it. And then we refresh the connection again. Okay, yes, if you take a look here, we have added a new attribute, a new column age here, right? Okay, now what if you want to drop this table, remove this table from the database completely? We say drop table, and then we say the name, right? TAs. Okay. Oops. And let's run this. Okay, and then let us refresh the connection. Yes, as you can see, the table TAs has been completely dropped from this database. So yes. Okay, now I will show some data manipulation by inserting the data, updating the data, and deleting the data from the table. So first, we will use a test DB as well. So use test DB as our database. And then we want to insert information into the student table. So insert into student table. And then now we specify which column, right? So and remember the student ID, we don't have to care about it for now, because as I said, it's automatically increasing. But yeah, name, current year, and hometown uh we want to specify. So name, current year, and hometown. And then the values of the input, right? So we want to specify values, let's say random name, right? So current year, probably year 4, and then hometown, let's say okay, and then let's run it. And then if we refresh this table, yes, this column has been added. Now we inserted the information. What if we want to update the information? So we say update the table, student table. Set what if we want to change at least year to year 4? So set current year to 4, where name equals to at least. right? Okay, now let's refresh again. Okay, now you see at least current year has been changed to 4. Uh, and then now what if we want to delete? So we say delete from a student table where we want to delete Zihan from this table directly, right? So delete student where name equals to Zihan. And then if we refresh, yes, it has been deleted. Okay, now this is the basic data manipulation in SQL. Okay, so now I'm going to talk about the join statement. How do we combine columns from uh, different tables together to join them, basically, right? So for example, take a look. We have two tables here, the department course and the course name. The department courses table, the primary key is course ID, storing the course detail. The course name basically just stores the name of the courses. However, we only want to extract two columns from these two different tables. The instructor name and course name. We want to see what's the name of the course that each instructor teaches. So basically extracting two columns from different tables. There are three types of join statement: inner join, left join, or the right join. So take a look. We have two tables, department courses or course name. If we use inner join, then when we try to combine the instructor name column and the course name column, it doesn't matter whether like if there's any information that does not match each other. For example, in the department course, you can see there's course number 7, but in the course name table, it only has 6 courses, no number 7, right? So it will not be shown in the result when we try to combine these two columns into one table. The this number 7 row will simply not show in the result table. However, if we use left or the right join, depends on which one you use, right? If you use left join, then this table, department course table, will be the left table. Course name will be your right table. And then if you try to combine them together, the left table does not, number 7 does not find any match in the course name table. So the value on the column that you have in the right table will be shown as a null value, which does not exist in the result, right? So let me write a statement first. So use API now, and then we will join them together, right? So first we'll use inner join. So select and then we define which two columns we want to join. Department courses from inner join. We use inner join first and then inner join course name on. Now we define what is their common column. Their common column is course ID, right? So equals to uh course name. I mean course ID. All right. Okay, take a look at the result. So obviously, they are joined together, but since we used inner join, even if this table does not find any matching value when the ID is number 7, it will not be shown in the result. However, what if we use left join? Look, if we use left join, then this will be the null value because the left table cannot find any matching value from in the right table's column when the ID is 7, right? So yeah, I hope now you understand the differences between the left join, the right join, and the inner join. The right join just basically you change the order of the table. For example, I change it to change this to course name, and I change this to department courses, and then I use right join. Oops. Yes, it basically produces the same result. Uh, it's the same as the left table. When the ID is 7, it cannot find any matching value from the left table. So yes. Okay, now let's talk about data queries. Basically, it means that retrieving certain data from the database table under certain conditions that we define. So let's talk about the basic select class first. So select star from department courses where instructor name is equals to instructor A, right? So now basically it retrieve all the informations that has the instructor name to be instructor A. What if we don't want it to be instructor A? Then we write the less and greater than sign, which means does not equal to instructor A. And now it's the opposite, right? Everything beside instructor A. What if we want the number of students to be between number of students to be between 200 and 300? Yeah, now basically satisfies uh, retrieve all the rows that has a number of students between 200 and 300. Um, okay, and then what if we want, let's talk about the order by class, the order by class. Select star from department courses, order by number of students in an ascending order, right? So basically now everything is in the ascending order based on the number of students, right? Yeah, order by class. And then what if, and now let's talk about the difference between the union and intersect. So basically union means or, okay? And intersect means and. So union means or, intersect means and. If we want to select rows that are based on two conditions simultaneously, then we should use and because both of these conditions must be met. If either one can be met, then use union, right? So for example, let's use our previous example, right? So we're number of students between 200 and 200, let's say 400, and intersect basically and we write another select statement here from the we're number of student where instructor name is not basically no row satisfies these two conditions at the same time, right? But if we change it to union, then yes, there are many rows that satisfies these two conditions, not taught by instructor A, but the numbers and or the number of students between 200 and 400. Okay, now I hope you understand the difference between union and intersect. And then I'm going to talk about string-specific queries. What is string-specific queries? Basically, retrieving data based on the string condition. For example, take a look at this table. We have different strings here, right, under the course name column. What if we only want to retrieve the rows that contains certain string, for example, contains science or contains lab from the column, right? We use string specific uh, retrieval method. So basically select a star from course name where course name we use the like class to perform the string specific query. Like let's say the percentage mark is pretty important pay attention because like the percentage part mark it does matter where you put it. So if you put it in at the beginning and then you um, write the target word after the percentage mark, for example, data, then it means that uh, the the information, the condition is that the string must be at the end of each string, each cell. And then if you do that, basically nothing will pops up, right? Because there's no course name that ends with data. But if you put it as after the data, right? Basically it means that it must start with the letter data. Then yes, there are two rows that satisfies the condition, right? And then what if anything that contains a certain letter, for example, contains computer? Yes, there's one course name that contains the letter computer, right? So basically, this is the concept of string specific query. Okay, now we will talk about data aggregation with two classes, group by class uh, and the having statement, right? So what is a group by class? Basically, group by sometimes we want the data to be grouped by certain attribute. For example, in this case, we can say we want the data to be grouped by the instructor name, and then we want to find the total number of students of all the courses combined together that each instructor has, right? So we will use a group by class, group by statement for this. The having statement basically means where. We can think of it as where class, but having statement is only used after the data is grouped. If the data is not grouped, then we will use where, okay? So now let's find the total, the sum of all the students that each instructor has, and then set some conditions, okay? Now we will aggregate the data, okay? So sum num and then we set the column for the data aggregation column as from instance group by structure name, and then having, now we are setting the condition, okay? So having sum of number of students greater than, let's say, 100, okay? Now let's see. Okay, you can see in this table, basically only shows the total number of students of the instructors who has a total number of students of greater than 100. If it's 50, there should be instructor C as well, because instructor C only has 56 students, right? So yes, this is the concept of data aggregation.